Well, students, we were discussing about the synchronous generator or alternator. Today we will find the relationship between frequency, poles and speed of an alternator. Now consider two-pole alternator, north-south, and this is armature, and this armature is moving in anti-clockwise direction. Now let us plot its waveform. At this point EMF is 0, at this point EMF is positive maximum, this point 0, this point negative maximum, and this point 0. So in one revolution, one cycle is completed. So this is very interesting phenomenon in 4-pole machine. Consider the 4-pole machine. Now we have seen that when conductor is on the neutral axis, in between the north and south poles, EMF is 0. When it is in the center of the north pole, positive maximum, center of the south pole, negative maximum. Now, in case of 4-pole machine, we will see what type of EMF will be generated. So, starting point is here. In between the two poles, EMF is 0. So, at this point, EMF is 0. North pole center positive maximum, south pole center negative, 0. In between the poles 0, center of the south pole negative maximum, and in between the poles 0. So here you have moved only half the rotation and one cycle is completed. And next, center north pole again positive maximum, interpoles 0, south negative maximum, and interpole 0. So in 4-pole machine, in one rotation you get 2 cycles. So when a conductor passes one pair of poles, one cycle is completed. Now we'll find the relation between the speed and the frequency here. If it is a 2-pole machine, in one revolution, one cycle is completed. In 2-pole machine, one revolution, one cycle is completed. In case of 4-pole machine, in one revolution, 2 cycles are completed. Means 4-pole machine. In general, if it is a p-pole machines, so cycles made in one revolution is p by 2. If there are 2 poles, cycle is 1. 4 poles, cycles 2. That means cycles are equal to half the number of poles. So when number of poles is p, cycles made in one revolution is p by 2. And cycles made in n revolution multiplied by n, pn by 2. Now n revolutions are completed in 1 minute. So this is cycles per minute. And cycles per second will be divided by 60. So cycles per second is called frequency. Cycles per second is frequency. Hence, F is equal to Pn over 120. This is the relation between frequency, poles, and speed. Now, another interesting phenomenon is mechanical degree is separate and electrical degree is separate. One cycle is equal to 360 degree electrical. Degrees marked on the cycles are electrical degrees, and movement of this rotor is mechanical degree. In 2-pole machine, mechanical degree and electrical degree are equal. But in 4-pole machines, mechanical degree is 180 and electrical degree is 360. So there is a relation between mechanical degree and electrical degree. Mechanical degree is equal to electrical degree divided by pair of poles. Means in 4-pole machine, mechanically it has moved 180 degree, but electrically one cycle is completed. That is 360 degree. So this is a relation between mechanical degree and electrical degree. Mechanical degree is theta electrical divided by pair of poles. If pair of poles is 1, both are equal. In this case, pair of poles are 2. So theta electrical divided by 2 is theta mechanical. So next, we'll discuss about some windings, armature windings. So we are discussing armature winding, and first we'll discuss the armature winding terms. There are certain terms which are used in windings. Just as first term is what is conductor, what is coil, what is turn. Difference between conductor, coil and turn. So this is a wire is formed like this. So this is called a single turn coil. One rotation of this wire is called a coil. If there is one rotation, it is called single turn coil. If there are three rotations, then it is called three turn coil. So this is the difference between turn and coil. And conductor is one length of this. This is one length is called the conductor. This portion is called conductor. These are three conductors here, three conductors here. So this is difference between conductor, turn, this is turn, and this is coil, three turns coil, and this is single turn coil. This is the relation between conductor, turns, and coil. Now one turn has two conductors. This is one turn there, one conductor on this side, one conductor on this side. So one turn is equal to two conductors. Now next term is pole pitch. पोल पिच मीन्स कि एक पोल जो है वो कितनी जगह घेर रहा है. जैसे यहां पर केस ले लें, एक टू पोल मशीन है तो आधा पोर्शन इस पोल के पास है, आधा पोर्शन इस पर. तो इस पोल पिच इज द स्पेस ऑक्युपाइड बाय वन पोल. नाउ वी टेक पोल पिच इन टर्म्स ऑफ स्लॉट्स. सो रेफर दिस फिगर. These are slots, and slots under one pole is called pole pitch. So pole pitch is number of slots divided by poles. Suppose now in this case number of slots are 36 and number of poles are 4. So slots per pole is 9. So this is called pole pitch. Then next is coil span. Coil span is distance between the two coil sides. This conductor is sometimes called coil side. Is sometimes called coil sides. Distance between these 2 points, these two conductors is called coil span. And in winding, it is necessary that one coil side must be under north pole and other must be under south pole. This is the conditions of winding. Both coil sides or both conductors of a coil cannot be placed under one pole, otherwise EMF will be 0. So for example, if I place one coil side here and other must be here. If one coil side, one conductor is under north pole, other side conductor must be under south pole in the similar position. Means if it is in the center, this must be in the center. So this is called coil span. And there are two types of winding: full pitch winding and short pitch winding. When this coil span is equal to pole pitch, when coil span is equal to pole pitch, the winding is said full pitch winding. And if this coil span is less than the pole pitch, it is called short pitch winding. Next is slot angle. These are slots. Every slot has certain angle. Formula for slot angle is 180 degree divided by pole pitch. So for this is the example. I have taken 4 pole machine, slots 36, number of phases 3. So pole pitch is equal to slots per pole is 9 slots. And 1 pole full pitch coil, slot angle is equal to 180 degree divided by pole pitch. So 180 divided by pole pitch is 20 degree. That means each slot angle is 20 degree. And pole pitch, this is the pole pitch. In space occupied by 1 pole in terms of slots, it is called slots per pole. So pole pitch is 9 slots. That means this pole is occupying 9 slots. This is 9 slots, 9 slots, 9 slots, total 36 slots. So this is called slot angle. So we have discussed the basic terms used in the armature winding. Next we will discuss the EMF induced in the alternator in the next lecture.